introduce Keith Packard with the history of X.
Well, it's notionally a history, but it's really tales that I've told to a lot of people. Bradley Kuhn actually encouraged me to put this talk together and submit it for his conference, CopyleftConf, in a couple weeks in Brussels. But as I was not planning on going to CopyleftConf, I said, well, I could submit that to LCA. This talk was added late in the program due to some people not being able to attend, and so it's a little rough around the edges, so I apologize for that. I usually like to spend a couple of months putting a talk together, but this time I had about 3 days. So here we go. Okay, first off, this is not a talk about anything my employer cares about. It definitely does not represent their opinions. These are my opinions. I need to tell you that because there's going to be a lot of opinion in this. And I will almost certainly be wrong. For those of you who lived through this history, please feel free to raise your hands and correct me where I do speak wrongly. Because 35 years of X is a long time, and I'm sure I've forgotten most of the important things. And as we all know now, our memories tend to rewrite things as we tell stories to others. And so this could be completely fictional. Okay. Who here was using Unix in 1984 or earlier? Not very many of us. For the rest of you, Unix in 1984 was entirely a closed source proprietary environment. There were no free software Unixes in 1984. This may come to you as a terrible surprise, but the licensing that AT&T applied to Unix allowed universities to use it, so students at universities had access to it, and eventually allowed corporations to acquire a license and build commercial products based on it. There was really no free software anywhere. The compilers were proprietary, the operating systems were proprietary, the graphic systems were proprietary. We lived in a land of copyright hell. Okay, so where does X come from? Remember 1984? That was the year the Macintosh, the original Macintosh, was released. It had a 512 by 380 some pixel monochrome screen. Why was graphics so terrible back then? Well, the real thing is that just around the same generation, somebody came up with a new way of doing memory. Before VRAMs, it was essentially impossible to build a competent frame buffer. You couldn't do high-resolution monochrome or color graphics until the VRAM was introduced. The VRAM was a dual-ported RAM. One side talked to the CPU, the other talked to the scan-out engine. Once that became introduced, we could build high-resolution workstations. Brian Reed and Paul Ascenti were at Stanford, students at the time. They were working on a distributed microkernel system called the V kernel. It did message passing over Ethernet, not TCP, not IP, Ethernet, because Ethernet was awesome. They needed a terminal program to run on their tiny little graphics devices. They wrote the V graphics terminal system, a VGTS. It had some interesting constraints on it, and then eventually wrote the W window system. That's kind of the first, because V was a distributed operating system, the notion of having a graphic system that could only talk to the local display, it never occurred to them. V was all about RPC. All the function calls or the operating system calls went into this distributed operating system and appeared and were executed on some processor, possibly remotely too. So RPC was the core of V. So of course the W window system was a distributed window system. The W window system was eventually ported to the VS100, the VAXstation 100. I have a picture of that, I think, on the next slide. It was ported by Brian or Paul. I'm not sure which of them or both of them were involved in that. I don't remember asking them back in the day. But they ported that at Stanford. Of course, this was all proprietary software, remember? Even the V system was proprietary. But they shared it with friends at MIT, Bob Scheifler in particular, who was working with Barbara Liskov. Yeah, amazing computer scientist. He was working on the Argus system as part of his master's degree, and he got a little sidetracked. How many of you get sidetracked like this? Yeah. He's like, oh, I've got this Argus system, which is another distributed, multi-computer, multi-threaded language environment using Clue. I really need to be able to debug more than one program at a time in GDB, or in this case, DBX. Could only debug one thread at a time. So I need multiple terminals to be able to debug my Argus programs. So he's like, oh, I know what I should do. I should steal this W code from Brian and Paul. and port that to Unix, get it working on the VS100, connected to a VAX, and off we go. Now I've got a terminal program, and I can get back to Argus. Well, he got a little sidetracked. He spent a couple weeks hacking on W, completely replaced the synchronous RPC mechanism, because V, of course, had synchronous RPCs, which was really efficient because it was basically the core of the operating system. But Unix, not so much. So we re-implemented as asynchronous, and a couple weeks later, pooh, we have, look at this, V, W, X, awesome name. Yeah, okay, so you choose the first metasyntactic variable name for your Windows system. And you think, and people are going to think you are the smartest naming person ever. Yeah. Okay, here is the venerable VS100. This is, unfortunately, all of the images in this deck. I could not find attributions or copyrights for any of them. So these are probably all, I'm hoping I've got some fair use terms allowing me to use the images, but when I publish the slides, I'll probably have to strip all the images out. This was the VS100. It's an awesome piece of hardware. Imagine what you have in your office is a VAX750. Who knows how big a VAX750 is? Yeah, it's two 19-inch racks, about 4 feet tall, with, I think, probably 4 or 6 8-inch squirrel cage blowers to get air through it. Is that going to be in your office? Probably not, but that's what this plugged into. It was a Unibus card. Unibus cards are about this big. The Unibus card that plugged into the backplane of the VAX ran, I think, 3 optical fibers from the Unibus card out to this device, which is a 68K based computer. Of course, it was just a terminal because you had your real VAX back in the background. Who needs a 68K when you have a VAX? It turns out that 68K was probably faster. It had a mouse, a keyboard, and a high-resolution screen. I think it was 1024 by 800 and some. No, it's more than 1024. I think I actually wrote this down. Sorry. Yeah, I think it's on the next. No, it's not even on the next screen. I think it's like 1100 or 10,080 some pixels. A crazy number. Okay, let me get off the stage again. I'm going to kill myself. This was awesome. Monochrome screen. Again, it's a 68K processor. It's got like 128 kbytes of VRAM, these really expensive dual-ported memory that allow you to scan out a monochrome screen at the whopping rate of 60 hertz. And it's got a lovely mouse and a keyboard. So now all of a sudden I have a workstation. I can run the optical fiber a long distance. I can actually have the VAX up on the 7th floor, I think, 8th floor of Laboratory of Computer Science at MIT, run the optical fiber down the plenums, because MIT was extremely plenum friendly, and run the optical fibers into my floor, onto Bob's office on the 5th floor. So you could actually have this terminal, which is a full-speed Unix workstation, sitting in your office. Amazing! Fantastic. Okay, let's see, the Unix workstation market. Unix was closed source, as we said. Most of the vendors shipped a proprietary hacked up version of what what Berkeley was working on, BSD. So they started with BSD 4.1 in some cases, 4.2 in other cases, 4.2C in some cases, and I don't remember if anybody started with 4.3. So everybody took BSD Unix, they got a license from AT&T, they got permission from Berkeley, and they started hacking the heck out of the source code because they needed to make it better, right? And they had awesome ideas on how to improve this great operating system. And every single one of these workstation vendors was going to take over the world and wipe the rest of the vendors off the market because theirs was so much better. And as a result, during that era, that's when the configure program came about, in about this era, early 80s. This is one of its famous lines. Who's ever seen this printed on their terminal? Yeah, this is the configure script that Larry Wall wrote. This was the best thing it could say. Congratulations, you're not running Unis. Unis was the Unix emulation that ran on VMS at the time. But in all other cases, it was like, well, this is some variant of a BSD-like operating system. I'm going to have like 6,000 pound defines to tell you how to compile your program for this BSD. That was awesome, right? We actually had portable software, kind of, as long as you were willing to recompile. So the whole notion of a commercial software market, which each of these vendors was desperate to create, was never going to happen because there was no standards. Okay, DEC's entrant into this, one of DEC's two entrants into this market was called the VAXstation 2. You can see I actually had one of these on under my desk at MIT. It's this rolling cart thing with wheels in the bottom. And it's a double wide system. This is color graphics. Okay, 1986, 1987, something like that. No, don't remember the exact age. It had an 8-bit accelerated color graphics screen. Amazing stuff. I love especially his outfit. I struggle to emulate his panache every day. Okay. Another common graphics computer of the era was the Sun 360. How many of you have played with the Sun 360? Yay! Okay, the difference between the Sun 360 and the VAXstation was the Sun 360 used a commodity Motorola microcontroller, the M68020, and it used a dumb Framebuffer, which is to say the CPU is responsible for drawing everything on the screen. Meanwhile, with our friend the VAXstation 2, it used a proprietary VAX microcontroller, and it had a graphics accelerator, which was connected via I don't even remember which bus it used to connect it into the system, but it had accelerated graphics, which meant the CPU could not draw into the Framebuffer directly. You actually had to interact with the graphics accelerator. That kind of sucked. Actually turned out to be worse than the dumb Framebuffer in so many ways. This was awesome. It had this really cool special mouse pad. So it had an optical mouse, but optical mice weren't all that awesome in 1986. It actually couldn't tell, it didn't have the ability to detect motion on a regular flat surface. So you had to use the custom mouse pad. Yeah, that was kind of cool. They had the advantage of not having a ball underneath it that got full of goo from the desk, and so it was a lot more reliable. Okay. So in 1985, 86, we had the early Unix Windows systems. The dominant Windows system, at least from my perspective, again, this is my story, was SunView. I saw SunView first as an undergraduate in like 1985. It was amazing. I had a megapixel screen, 1152 by 900 resolution. Yeah, I remember all the numbers. And it had multiple terminals and applications and little desktop widgets. It was awesome. What was the problem with SunView? Oh, you had to buy a Sun Workstation to run SunView. The Windows system was actually in the Unix kernel. So that meant to draw anything, you had to take a kernel call and go draw a rectangle and come back. Which meant that you had some protection from other applications drawing on the screen. Because other applications, the kernel would actually keep things isolated. Digital had VWS UIS, which only ran on VMS. This is their VAX Windows system, and I don't even remember what UIS stood for. I can't even backronym it today. I apologize. Apollo was a Unix-like workstation. It wasn't actually running a BSD derivative, as far as I know. It had its own crazy kind of network distributed stuff called Domain. And that included a Windows system. Apollo also had the distinction of having the only planar display in the industry, which meant that if you had an 8-bit Framebuffer on Apollo, you actually had 8 1-bit Framebuffers. And to draw a line on the Apollo meant drawing a line in every single Framebuffer separately. So it was really cool to watch it draw, because you'd see the colors slowly migrate from one color to the next as it drew in successive planes of the Framebuffer. That was great. I was actually working at the time at Tektronix, and Tektronix was demonstrating Smalltalk, but of course, Tektronix was insane. That's really a bad word. I apologize. The Tektronix management had a very poor idea of how to succeed in the Unix workstation market. They actually entered the Unix workstation market, I think, 4 times altogether, and exited it shortly thereafter each time. Yeah, not exactly a great business model. They were using National Semiconductor 32016 and 32032 processors, which had numerous bugs, and yeah, they kept trying to make them work. Not so much. They had an awesome Smalltalk machine. They eventually shipped a couple of those. It was fantastic. Again, 68K based. But because they're mostly an oscilloscope company, they didn't really have a close relationship with Motorola, and their national salesperson sold them down the 32016 river. Okay, so as I say, Bob Scheifler developed the early X Window system in about 2 weeks. So that's where our architecture comes from, 2 weeks of spare time hacking. We have a lot of systems like that in our world, right? I can think of things like Perl and Python and Tickle, JavaScript. JavaScript was not even 2 weeks, that was a weekend. Right? There's these legacy technologies. It's like, oh, I know, I need to do something quick just so I can get my job done. And here we are, 40 years later. Thanks, maybe you could have thought about that a little more. Yeah, that's what happens, right? Okay, so X11, X1 through X6 were used internally at MIT. They had a closed source license because it was, university research, and nobody really had any idea what to do with it. It was shared with friends informally. I think friends at CMU, I'm sure friends at Stanford and Berkeley got to take a look at this. But it wasn't published in any sense that we think of software publishing. Okay, X10 came along, and there were 7 and 9, X7 and 9 as well. X8 was, the version 8 was reserved, but those were just kind of incremental improvements on X6 as far as I know. X10 was almost usable, right? The X10 Windows system had monochrome and color support. It ran on PCRTs, the IBM PCRTs, Sun 360s. It ran on the DECstations. I think it probably ran on early HP workstations of the era. I know that I ported it to the Tektronix workstations that I had in my basement that I got out of Tektronix surplus because they were canceled. Yeah, Digital actually didn't have a Unix Windows system at the time. So Digital said, oh, I know what we'll do. We'll ship X10 on our digital workstations. Well, the problem with X10 was that it was almost a Windows system and it almost worked. And it was like, oh, we're getting there really close. Can we just make a few refinements? Let's see. Oh, and the other thing is the X10 distribution. You think of X as always having been free software, right? Well, X was distributed, in this era, X10 was distributed under the MIT license. I think X9 might have been the first release to have that license. The MIT license is not a strong copyleft license, right? It's as my friends from Berkeley call it, a copy center license. Take it and do whatever you want with it. You got copyright, copy left, copy center. Yeah. So the distribution actually contained a number of binary blobs. The digital rendering code for monochrome and color was both distributed as binary blobs. The Sun 360 port relied on underlying SunView code in the kernel to do all of its rendering. The only thing that actually shipped with X10 that was in source form was for the IBM PCRT. And that's because CMU, Carnegie Mellon University, was sponsored by IBM to do a bunch of work on building the Andrew system, another distributed work environment of the era. And they needed it to run on the PCRT. They were playing with X at the time, kind of on the side. And there wasn't any rendering code, and they had a pile of students. And so they just shipped the source code, because why would they precompile it? Okay, so I got X. This is my first exposure to X. This is 1986, I think. I just graduated from university. I've been working at Tektronix for a number of years, but I got to X10 on the VAXstation 2 GPX. We're building a C compiler and IDE of the era before the term IDE existed. X10 had a lot of warts. One of its awesome warts is X10 also did external window management, where a separate X application did the window management, allowed you to move and resize and iconify windows. But there was no way to put decorations on the windows with the window manager. So how many of you have ever used UWM or X10? Yeah, just a very few. The reason there were no decorations is because it was literally impossible to do. The application would have to draw those decorations. So the UWM, the window manager of the era, the only way you could manage windows was with amazing combinations of hotkeys and mouse clicks. So it was Alt left to move the window, Alt right button to resize, because there's no way to put widgets around it. So that kind of sucked. X10's rendering model, it was also very primitive at the time. It had very poor image management, which was kind of important. The rendering line and circle drawing code was fairly primitive. And it was being done mainly by MIT with little digital involvement, some people at CMU. They really wanted to get the broader, a lot of other workstation vendors had come into MIT and said, we'd really like to get involved with this. Now, why did they want to get involved with this system? Any idea? Well, right now, they were all competing against Sun, and Sun had the entrenched SunView Windows system, right? All of these workstation vendors are coming and saying, we really want to have software, but there is no software for our proprietary Windows system. So what if we all kind of banded together, created a new standard, and said, hey, this is now the standard Unix Windows system. You should come and port to us because we support multiple vendors, and SunView only supports Sun. Now, Sun was the dominant workstation vendor of the era. There were actually commercial applications shipping on SunView, right? You could actually buy FrameMaker and another desktop publishing application. No, way before that. There was another Interleaf. There we go. Interleaf was also available. And that was like a commercial publishing system. So people were using SunView to do things other than develop Windows systems. Why? I don't know. Yeah. So Jim Geddes and Smokey Wallace, who were both at Digital's Western Research Lab at the time, came up with a cool plan. I know what we'll do. We'll work to develop a new X standard, X11. We will donate a sample implementation done by DEC engineers in collaboration with a few other people, and we'll reset the market, right? All of a sudden, the standard Windows system for Unix will become X and not SunView, and all other vendors, Sun's advantage in the market of having a platform to ship software on will evaporate. Well, shockingly, it worked. They managed to sell it to Digital Management. They even managed to get Sun on board. It's like, sure, standards, those are awesome. We should join that too. I don't know why Sun agreed to this plan. Didn't work out. It worked out fine for them. So Digital Management bought into the plan. A team at Western Research Lab was put together. I'm sorry I didn't write down all of their names, and so I'm not going to try to remember them. And they did, and they were signed up to do the initial X11 implementation. Okay, so now X11 is going to be developed. We're going to start with a fresh slate, right? We're just going to start with a blank sheet of paper and develop a new network Windows system based on the ideas that we learned from X10. So X11 inherits essentially no code from X10. It inherited a couple of ideas, most of them bad. So X10 had window borders, which was a constant width area around the screen, so you could separate one window from the other. Now we're going to have external window management with the window manager being able to have its own decorations. And so we should probably let the window manager figure out what kind of borders to draw. But no, we'll leave borders in because X10 apps might want them. Okay, so the protocol work was developed in a cross-collaboration between people at Sun, at HP, at MIT. I think some CMU people were involved, and certainly at Digital. The protocol design work was done over the internet in 1986 and 1987. If anybody went to Dave's talk earlier yesterday, you'll learn that the internet in 1986 and 1987 was a challenging environment to work in. Literally, you were talking about USPS. No. X11 development was basically FedEx-based. There were two teams, one in Cambridge, Massachusetts, and one in Silicon Valley, doing development on the code and the protocol, and they could not copy. It's a tiny amount of code. It's a couple of megabytes. The internet was not functional enough for them to be able to copy the code and synchronize their development efforts overnight. It would just time out and fail, and time out and fail, and time out and fail. So most X11 development was done via FedEx. You know, it's amazing what the bandwidth and reliability of an airplane full of tapes is. So that really, the internet failure really changed the course of X development radically. Instead of saying, wait, maybe we should fix the internet, which happened the next year, they said, what we're going to do instead is concentrate the development with hired and paid developers at MIT. We're going to build a consortium, hire a bunch of developers. Pick me. I got picked, although they didn't know me at the time. concentrate the development at MIT and stop trying to do distributed development. Right? That would literally, they gave up on the notion of doing development over the internet because the internet of this era was seen as fundamentally broken, and Van Jacobson and team hadn't figured out what to do. Okay, so here we go. The internet is not viable. We're going to just put developers in an office at MIT and pay them with a pool of money from all these major workstation vendors. Okay? So I got hired. My good friend Jim Fulton was hired, and then we hired a couple of other developers in the ensuing months. But initially, it was Bob and Jim and I working on the second floor now of the Laboratory for Computer Science. How many of you have been to Tech Square in MIT? Yeah, not too many of us, have we? So this is where Project Mac happened. Project Mac was where Multics came from. It was a joint collaboration between GE and MIT and Bell Laboratories and a bunch of other people. It was an enormous project. Project Mac developed Multics. What does Multics precede in our world? Unix, exactly. So here we are at the origins of Project Mac, and I am so pumped, right? I'm at like the birthplace of modern computing. Project Mac was there. Lisp was started there. The symbolics machines were all over the office. The cable trays at MIT were full of every networking technology known to mankind because the cable trays were huge, and who would pull cables out because that was really hard. You know, thick net, thin net, I don't know, whatever kinds of, I don't even remember the kinds of networking there. I got an account on ITS. Which is the incompatible time sharing system that MIT had developed for the DEC-10. I got to have an account on a machine on Net 10. The machine literally had a Net 10, a real Net 10 internet address before they repurposed Net 10 for my house. Which is why my house uses Net 10 and not 192.168. It's like, I was there when. Yeah, I know, I'm getting really old. Okay. So the consortium was funded by consortium members, by enormous sums of money paid by consortium members. There were probably 10 or 15 initially, and it grew to 50 or so. We had an enormous pile of cash. The members, who were paying, by the way, also voted at all the standards. Okay, so what's happened here? We've gone from a multi-university, multi-corporation, free collaboration where everybody's allowed to participate to pay for play. Hooray! What did this do to our external collaboration? Well, the corporations were now excited. They were paying for MIT to do their work. So what did the corporations do to X development of this era? They stopped, right? There was no reason for them to spend internal money on shared code. That was terrible. External collaboration with universities basically evaporated at that point because they weren't members. They weren't allowed to contribute to the standards. So we stopped working with them. I remember taking one trip to CMU in 1989 or so, where we went to see what they were doing with Andrew, and they had built an entire toolkit based on X11, and it was fun, and we chatted with them a while, and then we went home, and that was the last we talked with these people. Because again, they weren't members. They had no actual say in what I was supposed to do. I was being paid by these corporations. Okay, so this is the same era that the GPL was started, right? The GPL did not exist in any real way when X started. I remember doing my first GPL software in 1985. 1986 was licensed under the general public license. There was no GNU project. There was no version on it. It was the general public license. So that I actually went back and looked. I released GPL software as my first licensed free software. I felt pretty good about that. Okay, so where was the GPL? Well, unfortunately, Richard Stallman, the author of the GPL and quite an interesting individual, lived at 545 Tech Square. He lived up on the 6th floor, I think. He had an office up there. He did not have an apartment, and we knew him extremely well. He was a challenging individual to get along with. He would regularly come down to our offices and ask us or kind of rail at us for not using the GPL. This did not make a positive impression on me. This was my first interactions with Richard directly. And I remember thinking at the time, this guy is a little, I'm not interested in talking to him because he's so challenging to work with. And so we should have listened to him then, but we did not because we knew him too well, I guess, and met him as well. He really was right. We need to remember that. Okay, the other thing, of course, is these corporate sponsors, they're all the Unix workstation vendors. Do they have any free software in any of their products? The only free software they have is the X Window system. That's it, right? Their kernels, their compilers, all their tools, everything is proprietary. So they really have no interest in free software at all. And in fact, they're very much dedicated to non-free software. That's where they make their money. Remember, each Unix workstation vendor was going to create a Unix distribution and hardware platform that was so awesome that all the other Unix workstation vendors would disappear and everybody would migrate to them. Sun got really close. And if things had turned out differently and Sun had taken over the world, our world would be a very different place right now. I don't know better or not. It turns out that me personally was powerfully affected by the pay-for-say policies of the MIT X Consortium, right? I would spend my time answering mail by people who paid my salary. I would not spend my time answering mail from people who did not pay my salary. Yeah, it turns out even me, who is a free software radical, went to a college whose college motto was atheism, communism, free love. Yeah, it turns out when somebody controls my paycheck, I too can be turned to the dark side. Okay, so X Consortium Standards. The standards process of the MIT X Consortium was that somebody would come up with an awesome idea, write a standard, spend a couple of years working within the consortium, generating consensus on what that standard should be, and then the consortium would ratify it. Now, the consortium at the time was all the Unix workstation vendors. Critically missing from this list was perhaps application developers, end users, researchers from universities who might have good ideas about where graphics is going. So we had all these awesome standards come up. How many of you have ever used any of these standards? Yeah. Okay, XIE, the X imaging extension, allowed you to do crazy stuff, putting images over the wire. PEX, the FIGS extension for X, there was a great plan. FIGS was, of course, going to be the GL killer because it was an industry consortium, and those always win over industry individuals, right? We've seen that happen again and again. FIGS was trying to SGI had the GL language, graphics language. The industry consortium was trying to put together FIGS. We implemented a FIGS extension for X called PEX. I worked a bunch on a low bandwidth version of X. It turns out that low bandwidth is not the problem with X. The problem with X is high latency, and that didn't touch that problem. Oops. Yeah. Yeah, and then of course there was X input version 1. It's important to realize this is version 1 and not version 2. Version 2 is a complete rewrite by Peter Hutterer, which is actually usable. Version 1 was this bolt-on stuff. Now the important thing to remember in this era was that the workstation vendors were trying to differentiate with their competitors. They did not want to increase the common base of functionality. So the X window system, as soon as XR1 shipped, the X window system was frozen in time. The core X window system did not change until nearly the year 2000. So for 15 years, the standard for the X window system was the same. No semantic changes. And that means that today you can largely run programs from 1985 or 1986 on a modern X window system because the semantics never changed. Now that's awesome for portability. It's a great story to tell your customers that their applications from last year will run this year. The problem is that technology changed. Computers got different over those 15 years. And as a result, X, which started way ahead of the PC window system, the Mac window system, and all these other proprietary window systems, it stopped. It stopped in 1988. It never got any better. And as a result, other things changed, right? Okay, I wanted to show you some of the workstations of the era. Is there not actually an image on this page? Oh, I'm sorry, my slides kind of suck. As I said, they were done rather hurriedly. Okay, DECstation 3100. This was the first MIPS-based DEC computer, right? DEC had been doing VAX VAX processors for years and years. Proprietary VAX processors had a fab. The VAX processors were getting slowly faster and faster. And then some crazy people in, excuse me, I used that word again, I apologize. Some advanced people in California came up with the idea of risk computing, right? And we had the flowering of risk processor design across the industry. We had the Spark processor, we had the MIPS processor, and we had a bunch of other stuff. Okay, so DEC built the DECstation 3100. This is my first story about where the GPL would have helped us a lot. The DECstation 3100 was a 16 megahertz processor. It ran probably 4 or 5 times as fast as VAXstation. 60 nanosecond clock cycle. It was just amazing. What could you do with that kind of power? Yeah. Okay, it was fast enough that they decided not to build a graphics accelerator and to do a dumb frame buffer. So this was essentially the DEC's equivalent to the Sun Spark Station or Sun 360, the same era. You know, commodity processor, a VRAM, dumb frame buffer, and a scan-out engine, and that was it. But the problem was with the X Windows system was the color frame buffer code, the code that could draw to an 8-bit frame buffer was extremely bad at the time. It was extremely primitive. So what did DEC do? Did DEC decide to collaborate with the MIT X Consortium and build a bunch of new frame buffer code? No. A friend of mine, Joel McCormick at DEC, decided to go off and write some new accelerated color frame buffer code that would be a proprietary advantage for their workstation. I, of course, didn't think that was a great idea, so he and I spent the next 6 months competing, me doing free implementations under the MIT license, and he doing proprietary implementations for their operating system on writing color frame buffer code. And the result was the CFB code that we all know and love. How many of you have seen the color frame buffer code? Yeah, the CPU processor is an evil tool.
Could you see your code, but you couldn't see his code?
Yes. Yes. My code ended up being faster. Yeah. There were some optimizations that I should not have taken. Okay. Okay. If the X server had been released under the GPL license, we would have collaborated. Right? We would have been forced to collaborate because that's what the license does. And I'm pretty sure the result would have been better than what we came up with either individually. No doubt. He was a much better programmer than me in most ways, but I couldn't see his code and he couldn't share it with me. Okay. Here's another adventure, the News Windows system. This was a proprietary Windows system done by Sun, written by James Gosling and David Rosenthal. How many of you know what else James Gosling has done? A little language that he wrote, yeah. This is one of his earlier efforts. He also was an early author of Emacs while he was at CMU. He used the office next door to my friend B-Dale while he's developing Emacs. So B-Dale still has floppy disks with Gosmax source code. So the network extensible Windows system. This was awesome. PostScript based. There were some interesting design choices in this Windows system. I have a different talk that I could probably give about why I didn't think news was such a great idea. But it had a tremendous advantage over X. It had PostScript in it, which meant that it had the PostScript rendering model. It was a competent, well-designed page description language. Adobe had been working on it for years. I'm sure they had collaboration with actual graphics people, unlike X. And so you actually could do really interesting drawing stuff, right? You could do rasterize things really nicely, much better than X ever could. So the problem was, of course, was that News was a proprietary Windows system, and Sun had committed to using X as their standard Windows system. But News was better in some ways. So what they decided to do, this is the crazy plan, they decided to merge the X11 News servers into one source code base. Which meant that you had a single Windows system that could either run News applications or X applications. The awesome part about News was that the window manager was actually in the Windows system server. And so it had to then kind of grow and learn how to be an X window manager inside the Windows system server. Of course, the X11 News server was going to take over the world because it was the most awesome idea ever. And so it was closed source, a proprietary advantage for Sun. It used, of course, steaming piles of the X Windows System sample implementation. But again, we couldn't see the source code because X11 was licensed under the MIT license. So even though there was another PostScript implementation done by Adobe Display PostScript, this was used on the Next in the Next system, in their Windows system, and Adobe also sold binary blobs for Unix workstation vendors to merge into their X implementation, so you could have Display PostScript. Now, Display PostScript would have been awesome, right? It would have been awesome to have a new rendering model, but it was a proprietary advantage for HP and DEC. I think maybe IBM might have done it as well, which meant that application developers couldn't count on it being present. So as far as I know, there were no significant commercial applications ever developed that depended upon Display PostScript, right? So here we are crushing the market because people want to have a proprietary advantage. We have no way of developing applications. Again, if X had been developed under the GPL. Yep. OK, in the era, here's what the free Unix desktop looked like. TWM. This may well be a snapshot from my machine. I don't know. It's on the Wikipedia page. Isn't that amazing graphics? Doesn't that look incredible? Here's what Open looked like at the time. This is SunView running on a Sun workstation. Yeah. Does that look a little more humane, a little more stylish, maybe a little more usable? Yeah, actually it was a lot more usable. Similarly, here was Motif and CDE, right? I think, I'm not sure, but I think Motif was where they came up with this cool hack of using 3 different colors for the buttons to indicate pressed versus not pressed. It's just 3 different shades of gray. Right, it gives us this cool 3D effect. SunView adopted that. I think this version has that. Yeah, the original SunView did not have the 3D effect, but you can see the shaded buttons here that give that little pressed in effect. Yeah, I think Motif invented that. I'm pretty sure they did. Both of those were closed source. Motif was closed source. OpenLook, all of the OpenLook implementations were closed sourced. We had no standard free software version of a toolkit running on X. What did that do for application development in the X environment, right? If you're an application developer and you come into the X market and you think, oh, cool, we have a standard Windows system. I can ship the same code everywhere. Oh, everybody has their own toolkit. Well, that's not going to work out well. Yeah. The free one was called the Athena widgets. You saw what that one looked like. It were all based, there was an implementation of OpenLook based on the same underlying toolkit, the X Toolkit, as Motif. But the way that XT worked with OpenLook and the way that it worked with Motif was essentially completely different. You couldn't mix and match bits of an OpenLook app and bits of a Motif app. You had to either go all in Motif or all in OpenLook. So even though they were notionally based on a common library, they weren't practically usable on top of this common library. So X had this famous line mechanism, not policy, which is to say we don't try to specify what things are going to look like or how things are going to work in the underlying Windows system. We'll let applications put that policy on top. Well, in the X Toolkit, it turned out that that really wasn't possible. You had to have policy in your application toolkit. So what XT did is it said, well, every policy we can think of, we'll put that into the toolkit. That's how we're a mechanism and not policy. Yeah, it didn't work great. There's OpenLook. There were a couple of implementations of OpenLook. SunView, which was the thing that ran, remember the SunView stuff that ran as a proprietary Windows system? They took that same API and made an X toolkit called XView. Then they made OpenView because their customers said, oh, but we have to be using the standard X toolkit. So Sun and AT&T, I believe, spent an enormous amount of time creating a worse toolkit in terms of application development because they were forced to implement it on top of XT. Yeah, not a great idea. Motif. I think I said all of this stuff. Yeah. OK, so in 1992 or 1993, X kind of stopped developing because the Unix market had collapsed. And it collapsed because of what the Unix vendors were trying to do. All of them, instead of building a commons where they could collaborate and build systems that would actually allow application portability and cross-vendor development, and instead of working together, they decided to build their castle walls taller hide inside, and eventually the roving hordes outside overran the castles, and we got to the decade of Windows. And I think that is about the end of my talk. Yeah. Windows happened. And Windows took over because you could actually develop applications on Windows and ship them to all of your customers. It turned out to be important. Who knew? Yeah. OK. So that's the end of my talk. Thank you all very much for coming and listening.
Thank you, Heath, for that amazing talk.
Oh, thank you very much.
Very engaging. Unfortunately, we have no time for questions. So feel free to chase him in the hallways.